The second case in which the internal rate of return rule can fail is the case of mutually exclusive projects. And here what we're referring to is the case where a company has two projects that it could take on, but it can't take both. So for instance, it might be the case that we are building something or considering a project that builds something on a piece of land. And so we might build a bank or a bar or a grocery store or a gas station, but we can't really build all of them or even two of them. Once we build one thing, the land has been used. And so when we have the case of mutually exclusive projects, it's possible that the internal rate of return rule gives us an incorrect answer, because it's also possible that we prefer one project to another based on the discount rate that we use. And so if the discount rate is changing, we might switch the project that looks better to us. And you can see how that happens here. So we have two projects available to the Cowboys organization. They can take on the projects as long as they are net positive NPV, but they can only take one. Project A requires an initial outlay of $50,000 and then pays $32,500 in years 1 and 2. Project B requires an initial outlay of $40,000, but then pays $32,500 in year 1 and $20,000 in year 2. The required return for any project the Cowboys take is always 10%, and the question is, which project should we accept? So the way to solve for these problems is to analyze both projects individually. So we have project A and project B. And we can write out the cash flows for each project. They have an initial cost. For project A, it's $50,000. For project B, it's only $40,000. And then they have 2 years of cash flows, positive cash flows, that they're going to bring in. For project A, it's $32,500 in both years. But for project B, it's $32,500 and then $20,000 in year 2. So we can solve for the net present value and internal rate of return for both projects. I can show you that here on the calculator. We go into our cash flow environment. We clear our work. Our initial cash flow for project A is $50,000. We make that a negative. Our first cash flow is the first year's worth of cash flow, $32,500, and we set that with the enter button. And now we have an opportunity to use the frequency button. Notice that these two cash flows are the same, so the first cash flow repeats. And that means we can change the frequency here to 2. And then we're done. This has told the calculator to repeat this cash flow 2 times. And that's all the cash flows that we have. And we can stop here and we can go straight to net present value. Alternatively, we could just type in $32,500 twice. It's only 4 more button presses. It's not like it took any more time. I is our discount rate, and the projects for the Cowboys organization, discount rate is always 10%. We solve for the net present value by pressing compute, and for project A we see a net present value of $6,404.95. And so we know that we take this project. This is greater than 0. Net present value rule says we should accept the project. We can solve for the internal rate of return by pressing IRR and then compute. It'll think for a minute and give us an answer of 19.4267%. Again, the internal rate of return rule would tell us to accept this project because this is greater than the required return on projects at this risk level. So we would accept project A based on both NPV and IRR rules. Now, project B has slightly different cash flows, so we'll go back into the cash flow environment and clear out. Our initial cash flow, our initial cost is $40,000 for project B. We make that a negative. We set that value. The first cash flow, C01, is $32,500. Now this cash flow doesn't repeat because the second cash flow is $20,000. So we're going to have to enter both cash flows individually. But once we're done entering the second cash flow, we can go straight to calculating net present value. We enter in the 10% discount rate because all projects for the Cowboys have a 10% required return. And we go down and compute our net present value, and we get $6,074.38, which again, on its own, we would accept. This is a greater than zero net present value, and we should take any project that has a greater than zero net present value. We can solve for the IRR as well by pressing IRR and compute. It'll think for a minute and give us a rate of 22.1749%. And again, just based on the internal rate of return rule for this project, that is greater than the required return, and so we would accept project B. What I want you to notice is the comparison between these two projects. Notice that if I decide which project to take, remember I can only take one or the other. So if I'm going to decide which one is better, and I look at the net present values of both projects, I would prefer project A because it has a net present value that's higher than project B. On the other hand, if I decide based on the internal rate of return, I would take project B because it has an IRR that's greater than project A. So which one do I take? The answer is not quite as simple. Or perhaps a better way to say it is that the answer is simple. Always decide based on the net present value rule. The IRR here can lead you astray, and the reason for that is not quite as simple. The reason the internal rate of return can cause you to change your can cause you to pick the wrong project is because at different discount rates, the net present value and internal rate of return might be different. This is an idea called the crossover point. The crossover point tells us at which discount rate, at what required rate of return, we would prefer one project over the other, and at what level we would prefer the opposite. And so what we need to do to determine the crossover point is invent a new project. So here we need to invent some project C that isn't a real project. And we create the project C by subtracting the cash flows of project B from the cash flows of project A. So it looks like this. The cost for project C, and again, these are all invented, is the result of project A, negative 50,000, minus project B, minus negative 40,000. Which is negative 10,000. And then the year 1 and year 2 cash flows for our new project C are the same. 32,500 minus project B in year 1, 32,500, which is 0, and 32,500 for project A year 2 minus 20,000 for project B year 2. Which is 12,500. Then we calculate the internal rate of return for our fake project C. Like this. Go back into our cash flow environment, clear out, and then enter these fake cash flows for project C. Initial cost of 10,000, which is a negative. 0 for our first year's cash flow. And 12,500 for our second year's cash flow. Then IRR and compute. And we get 11.8034%. Okay. This is the discount rate above which I will prefer B to A. and below which I will prefer A to B. And we can see what this looks like if we draw the net present value profile for these two projects. So on one hand we have the net present value in thousands, and on the other hand we have the required return, the discount rate, in percent. So we'll draw 5%, 10%, 15%, 20%, 25%. And on the net present value side of 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. And we always know 2 points, remember, on the net present value profile. The first point is the net present value itself. And for these projects, at a 10% required rate of return, the net present value for project A is 6404. And the net present value for project B is 6,074, which means we slightly prefer project A because it provides a slightly higher NPV. We also know the internal rate of return, and the internal rate of return, if you'll recall, is the rate at which net present value is 0. And for project B, that's 22.17%, where for project A, that's 19.42%. And now that I know 2 points on the line, I can draw both of these profiles. I can connect the point from project A's net present value to project A's internal rate of return. And I can connect the point from project B's net present value to project B's internal rate of return. And hopefully now you notice what I'm talking about. At this point right here is what we call the crossover point. And if I was an artist and not a finance professor, this would actually match up with 11.8%. And it's pretty close, I suppose. So notice that below, for any discount rate less than 11.8%, I prefer project A because the net present value will be higher than project B's net present value. But for any discount rate greater than 11.8%, I prefer project B because the net present value for project B will be greater than the net present value for project A at all of those discount rates. So the question for us is the discount rate we used appropriate? If it is the appropriate rate for the risk of these projects, then I'm happy with my choice that project A is better. But if it is not the appropriate rate, or if we're not convinced that our assumption about whether it's the appropriate rate is correct, we may at some point prefer project B if we think the project is risky, more risky than the rate we've currently used. And so here we can't use the internal rate of return on its own to decide whether to take a project or not, because it is not dependent on the discount rate, and our decision here is going to be dependent on the discount rate. And so we have to make our decision based purely on the net present value.